Long division. So as I mentioned before, we've always had degree of numerator less than, strictly less than, degree of denominator. Now, if you don't have that, we have to do what's called long division of polynomials. Now, what I'm going to do with long division is I'm going to do it the way the textbook does it. If you went to high school in Quebec, as almost all of you did, then you probably did it a slightly different way. Equivalent, but just things are rearranged in a different way. You can do either way you want, but I will do it the textbook way. So I'm going to do a long division. So in this case, you see that the degree on top is 5, the degree on the bottom is 3. So a long division would be good to practice here. Now, it's just like if you're doing 2 into 7. What would you do? You'd say, oh, it goes in 3 times. All right, and then you go 3 times 2 gives me 6, which you put below there. Then you perform a subtraction. And then you say, this is 7.0, blah, 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 and you descend the digit automatically. Then you repeat your process. You say 2 goes into 10 5 times. I recommend you try to keep things lined up. And 2 times 5 is 10, 0 remainder. Bada boom. So that's basically what I'm going to do over here. I'm going to say x cubed goes into x to the 5. How many times? Well, it's x squared, right? X squared times x cubed is going to give me x to the 5. Then I take x squared times this dude, and I write it underneath. You want to keep things lined up. Okay, you'll notice I'm taking pains to keep things lined up. I've even inserted some missing terms here. That helps me keep things lined up. Okay, just like before, I do the subtraction. And what do I get? I just get negative x squared. Because 0x squared minus 1x squared is negative 1x squared. And you can descend these terms. And then you would start over. You'd say x cubed does not go into x squared, so I stop here. And I call this my remainder. Now, how do I write this out? What have I learned from this exercise? Now, what can I do? Let's go back to our example on the right. 2 into 7 was 3, 6, and then 1. And let's say we were to stop there. This would tell me that 7 over 2 is equal to 3 plus 1 over 2. Now look at where everything ended up. This 1 ended up on top here. This 2 ended up here. And the quotient 3 ended up here. So I'll do the same thing with my polynomial long division. I will say x to the 5 plus x minus 1 over x cubed plus 1 is equal to the quotient, x squared, plus the remainder, this guy, over the original denominator. Okay, so that's a technique we'll use.